Why do stars blow up? Let's imagine a star 21 times bigger than our sun. The star wants to compress down because of its gravity amount, but it doesn't because of nuclear fusion, which causes it to push out, right? So that nuclear fusion doesn't last forever as it runs out of fuel. First, it starts with hydrogen and burns out of 7 million years and it turns into helium. That helium starts hitting with more hydrogen and other helium atoms to form carbon and oxygen, and that lasts 500,000 years. And each stage, the fusion and fusion turns bigger and bigger elements will last lower and lower amounts until we reach iron. And iron is too big for it to fuse with the amount of energy that the star can provide. So we're we're stopping the exothermic reaction. As we see here, we can see the different layers. In the middle is the iron core, and the outside is the other layers of where the fusion is happening. And the main reactor, which is the iron core, which is basically the ashes, stops working. So because of that, gravity starts winning and starts compressing. Now, when it starts compressing, it compresses so fast. It's a fraction of a second. So what happens? When it compresses, the electrons, which are these tiny things that jiggle around, take too much space. So they force them with protons to flip their core and turn into a neutron and a neutrino. A neutrino is tiny ghost particle that can go through and go away and take away the energy, while the neutron stays and can get compressed even further. The neutrinos, there's going to be a bunch of them, and they take 99% of the energy with them. So that gives less resistance to the collapse and just makes it even more dramatic. Once the density hits 10 over 17 kilograms per meter squared, it can't collapse anymore. That's the maximum those neutrons can compress to. So, like imagine you take a bouncy ball and you throw it at a fucking concrete wall, it's gonna bounce back, it's gonna rebound. So that shockwave starts sending it out, sending all of those other layers that we were talking about, the hydrogen layer, the silicon layer, sulfur layer, shoots them all out with those neutrinos, causing external nuclear fusion. No, all elements that are heavier than iron are made from that shockwave. Now, after that shockwave, we are left with the neutron core. It's super, super, super dense, and we're just left with it. Now, if that core has the mass of 2.2 solar masses, which is a little over 2 suns, then it's going to become a neutron star if it's less than 2.2 solar masses. It's going to have a gigantic magnetic field, it's going to spin super fast, and it's going to be super small. Now, but if the core itself, the neutron core, is bigger than 2.2 solar masses, then the core is going to implode and turn into a black hole, where the gravity is so big, not even light can escape. You hear me that? Light can't even escape. Thanks for watching.